So what I present today is the last two we developed in a lab. It was a work that Ivan Hidalgo Senalmor, he's also in the audience, developed. He is now doing a PhD in Turku in Finland with Guillaume Jacquemet. Some of you may know him. And I mean, both him and I, we are very happy to answer any questions if you want now during the talk, or if you want to reach us. And like we for us, it's very nice when people uses our tools and gives us feedback, because it's really the only way to improve the tools we do. So what is deep learning for microscopy everywhere about? I have these beautiful slides from Ivan. So we know that reproducibility, right, is an issue in life sciences in general. And this was our main motivation to develop these tools. So basically, we have some experiments that we do at some point of the year or at some point in our life. And then when somebody tries to reproduce it, it's complicated. This is known experimentally, and this also happens with computers. And I know some of you are engineers, some of you work also in microscopy facilities, so you are very aware of like how difficult it is basically to install and reproduce tools from Windows to Mac and so on and so on. So basically, in the era of deep learning, this is even, I would say, a bigger problem, because we depend on many packages from Python. We depend a lot on the way we treat the experimental data, the environments we use for the GPUs and what's not. So what means in practical terms reproducibility is to be able to send the entire environment with the code, with the scripts, with the packages to a new person in the way that they can actually just reproduce the environment. I won't talk about replicability, because that is even more complicated. And one of the issues is not only to do it today, but also in the long term, right? And this in science is quite critical, because it might be that I develop a new method, but it's only like in 2 years from now that people will use it. So just to give you some context, the unit was developed or was published in 2015. And it's now when we want to use it. And if any of you tries to reproduce the environment that the original developers encoded, it's actually extremely complicated if we don't virtualize it in some sort of box. And let's not talk about doing it in different workstations. So what we did was, this is not new, it's to find a way to streamline method containerization. So in case this is new for some of you, containerization means that we build a virtual machine inside our computer, and we can install whatever we want. And we do this with Docker. So basically, we put in these containers, in these little boxes, all the dependencies, all the code, all the instructions that we need to actually replicate this virtual machine and create and build exactly the same environment that we had when we were developing our methods. And the idea is that we wanted this container to be actually available for any operating system, no matter if it was Linux, Mac, or Windows, or any other. So basically, this, as I said, is not new. It's very well known among developers. What we need to build these containers is to create a Docker file, like a recipe that we have to follow to create this box. And then Docker is a very, very kind of smart tool that we follow the recipe and we create this container, and then we can have these same environments in any computer. And we decided to use Docker because it's basically open container initiative, so we don't need to pay or anything to use it. And because this might get a bit complicated, Ivan wrote a very, very nice blog post in Focal Plane explaining why this is important and like the steps and definitions. So if you want to know more about it, I would invite you to go to this very nice and I would say friendly story that he wrote. So taking these resources, what we built was first a way to automatically containerize workflows, right? So basically, with our tool, a new developer, a new method contributor could follow our standards and automatically build these little boxes, these containers, right? And what we do, because of course, building the containers, it's usually not straightforward. And when we try to follow these recipes, due to maybe availability of Python packages that sometimes they just remove them from pip, for example, or they remove them from conda, it cannot be always possible to build a container. So what we decided was, okay, our tool will not only automatize the process, but once we know that the box is created, we will publish it in Docker Hub. It's kind of like a repository for Docker containers. And this, what we do is automatically in GitHub through something that is called continuous integration. So basically, we built a workflow that will check that the standards and the format of the methods, right, and to containerize it is reproducible, that we can build a Docker image that is actually compatible with Linux, Mac, and Windows. And once all these, let's say, unboxing or encoding of our method is built and passes all the checks, we will publish it in Docker Hub, and also it will be automatically connected with the bioimage model. So, and the idea is that then once this is publicly available, we have a Docker container image that the user can just pull, and it can install always, not only today, but in 2 years, 3 years, 10 years from now, this same box with all the dependencies on it, and it will be able to reproduce originally the method contribution whenever it's needed and wherever it's needed. So all this is the ecosystem that Deep Learning for micEverywhere kind of provides for developers and users. And for users, that I think is the interesting part, because it's really the part that they cannot do because they don't have maybe the expertise to access this programmatically. The idea is that we provide like a user-friendly ecosystem in order to pull all these containerization. So also, because it's not only about, okay, containerizing, but it's also about providing the workflows, right? So what we did was to connect the tool with zero-cost deep learning for microscopy, debugs, the bioimage model too. So it already has all these kind of available user-friendly tools, containerized and available. And this was an issue before with zero cost, for example, because with Google Colab, the dependencies were changing all the time, and it was very, very difficult to reproduce the environments there. So this is the collection that we provide at the moment, but of course, anyone is welcome to pull their own notebooks, or to pull their own workflows and containerize them automatically. And they, like with this platform, by joining, let's say, the collections, they wouldn't need to worry about building all these continuous integration system and so on. So for users, the way it works is that they download the tool. They just do one click, like it's just an executable, and a user-friendly interface will appear. And in this user-friendly, the interface, they can choose the notebook they want to run. They will need to choose, okay, where is the data in their own laptop or in their workstation, where they want to save the results. If they want to use a GPU, so the system will automatically check if there's an NVIDIA GPU available or not to train these models, and then it will install automatically all the dependencies, the containers, and it will launch directly the Jupyter Lab with these user-friendly notebooks. And then these notebooks, although they are running it locally, or they can run it also in the workstations, are exactly the same that we have in Google Colab and so on. So this is a bit the idea. And in summary, basically what we aimed was to support reproducible, transferable, and transparent pipelines for deep learning especially, but I mean, it can also be used for any other type of pipeline programmed in Python. And of course, using these containers to support the long-term reproducibility. And this for us, it's kind of key also to avoid all the time issues and like people not being able to use your methods just because there's one package that is missing. And of course, to get like a centralized point to disseminate all these containerizations. So this is the entire team behind Deep Learning for micEverywhere, and who made this tool possible and provided like feedback and new notebooks and a lot of infrastructure. And I want to, before finishing, thank, of course, the Ricardo Enriquez lab, where I'm doing my postdoc, and Ivan is here, you can also see him. And I would like to thank the AI for Life project. I'm not sure if you hear about it, but it's a European infrastructure project that supported the development of the tool and also the bioimage models and the team there. So because I think it's more interesting to see how this works. I'm not sure if you have questions before going into the practical. Let me see if I can see the chat here. Okay, yeah. So I will just close this one and I will show you how it works, unless there's any question there. No?
I just have a question. Will there be a container for each version of the tool when the tool is updated, or how will this work?
Yes, so exactly. So what we do is like we freeze, right? One version of one notebook with one dependency, and that would be one container. Let's say that now you update it. So then when you update in the specs that are in GitHub, the continuous integration system will automatically see that you have a new version. So it will launch again the containerization. It will check again that it works, and it will upload a new container with a new version number. So then, let's say that you, for some things, you want to use one version, or for some others, you want to use another version. So you can always decide what is the version you want to pull. And anyone who uses it, for example, for an issue, can always report, hey, I'm using this version of the container, it's not working, whatever. Yeah. So it will be one container per each pipeline, but you can decide what is inside the container. I see more questions here.
Yeah, I have a question about the container. For example, I work a little with Biop Desktop, which is kind of container and Docker image. And there was a problem about, for example, Cellpose 2 that download the model, even if you have it in the container, then it starts downloading the model, and the model was broken on the GitHub website, and they have some issue due to that things. When we download the container with DL4MicEverywhere, did we download absolutely everything, or did we need to have an internet connection to continue to have some other download after having the whole image?
Okay, so once you, I mean, for the installation, yes, you will need connection, right? Mm-hmm. But then, I mean, so in the specs, we specify all the things that need to be downloaded. Mm-hmm. And once you do that, in theory, you don't need internet connection. Now, if you have a notebook inside that calls some code that requires to download a model, like we cannot control what is inside the code. That's the point. So if your notebook has some kind of pipeline that is always downloading a pre-trained model, then you will need connection. And then you will like we cannot, I mean, so we check that the containerization is correct. We don't check that your pipeline is working. That is like the responsibility of the person who contributed the pipeline.
Okay. And so it's not a specific part in the list of what they need to do if they want to publish in deep learning. It can be something that say you have to, everything has to work offline, for example. Can it be something like that?
So we didn't have that, we don't have that requirement. I mean, also because, so some of the collections we have, I mean, maybe I can show here. So these are the collections we have. Some external, anyone who wants to just use our system to containerize, but they want to maintain notebooks. The zero-cost deep learning for microscopy notebooks that we maintain and we are responsible of, and the bespoke notebooks also, these are from deep learning for micEverywhere that we are also responsible of. So the issue, not an issue, but these two collections, they are compatible with Google Colab, for which you will need internet connection. So for us, that requirement will limit a lot the usability of these pipelines. I mean, I think this is really personal. Sometimes you may want things to work offline, sometimes not. It's not a requirement, but you can also document like this tool, or not this tool, this workflow works offline, and you can, I mean, and if it doesn't, then somebody should raise an issue or some message.
Okay, thank you.
Thank you. I think there's Alex, right?
Yeah. I have a small question because I tried and I don't understand something. When you have big data, how your system manages the big data in 2D or in 3D? Because maybe some systems will require only small data set, 512 by 512 or something. But if I have real microscopy images and my images are quite big, your Dockers can't handle it, like you put an option to split, I don't know, to cut the image, or if the image is too big for your system, nothing will happen. I don't know.
Okay, so I think it's a different matter, right? So it's independent. What I mean is like your data is on your workstation, right? Or on your system. And the size doesn't really affect the container if you don't want to include this data inside the container. So the way it works, and I will show you now, is like when you install this container is like a machine to which you are telling my data is here, but this data is not getting inside the box. So the size of the data doesn't affect. So basically, the containers, let's say that is the software part, right? And it will launch or it will run some functionalities with the data that you have somewhere else. And we just need to tell, hey, or you as a user, you will need to give access to this software to the data, right? So it's really not a problem at all. Then another thing is that because the idea is that you are going to use your computational resources, right? So if computationally you are not able to deal with such amount of data, then it's a different issue. But I can show you now. I think there are no more questions. So basically, the central point of the tool, maybe I can do a smaller, I'm sorry, is our GitHub repository. And I mean, here we have like videos and many instructions. And if you find anything that is not clear, please raise it as an issue or send us a message so we can update it. So basically, you will need to download the zip file or clone the repository if you are familiarized with Keep. And the idea is you can use this remotely as well. I think there's a question. Just interrupt me whenever you want to ask a question, because I cannot see you very well with the monitor. Okay. Yes, Aurelian.
Yeah, sorry. So it was a question not related to just what you are showing, but in terms of the reproducibility, when you mentioned that you can use, for instance, a code that you Dockerized 5 years ago and now you want to use it, I have a question linked to the CUDA parts. So if you want to run it on a GPU, and let's say I have a new workstation with the latest CUDA driver, and if you try to run a latest TensorFlow version of 5 or 10 years ago, this would be an issue, right?
No, because we are also specifying the CUDA drivers and libraries that you need in the container. That's the magic of Docker. That when you install that virtual machine, that virtual machine comes with the drivers that you needed 10 years ago.
Okay, cool. So
yes.
Inside the Docker, you have the previous driver, but this driver, okay. And so, it works, for instance, it will work with even a modern workstation. Yeah.
Yes. So, I mean, as long as the NVIDIA GPU that you have can launch with the old versions. I mean, it's always, the limitation is always the hardware, right? Like the hardware needs to be compatible with that. but that's why it's tricky. So containers have been used in computer vision for years because of that, because you need many different CUDA versions, cuDNN, and so on. And it's a solution that is known in that field, but it's complicated to program it. Like, it's not straightforward to always make the same container if you don't know very well how to build this recipe. So what we did was to actually, in our format, I will show you. So when we speak about format, we are just speaking about a configuration file, that is this text file, right? And this is this is compatible with the SU, but basically here, what we do is we defined where were the minimum specifications that we needed for our hardware to be able to run the code, and also the Python package. So here are the CUDA versions that we need for this specific workflow. And this is different from what I have installed in my machine, in my original workstation, right? And that's the point, that it will install with that. And the same for the Ubuntu version that we need. So basically containers are like Ubuntu machines. The Python version that I will need, the notebook version. So these are all the versions that we can update. This was a question from Lene. Then when we update our workflow, we can basically change this, and then we will create a new container, a new virtual machine.
Cool, thanks.
You're welcome. Okay, so yes, so this is the format I was talking about, and our idea is, and this goes with the initiative from the bioimage model SU, is that the workflows are documented with the names of the authors, the manuscripts that we need to cite with the methods, and here are the versioning, and this is the tag. This is like the name on Docker Hub. Docker Hub is this repository for Docker containers that I was mentioning before. And if you want to download a specific version with a specific container that inside has a specific packages and workflows and pipelines, this would be the unique identifier, right, of this container in Docker Hub, with the version for the container, and also the version of deep learning for micEverywhere, like the version of the tool that was used to build this image. So basically, as a developer, if you want to contribute, like if you want to containerize your tool, you will just need to make a pull request in these external notebooks with a folder with your workflow and the format. And the format can be as simple as this. You just need to specify or to tell the tool where are your requirements, where is your notebook, and then some versioning, some CUDA versioning, and some Ubuntu. If you don't know some of these, you can always try the ones by default that you have when you develop the tool in your workstation, and let the CI check if everything works, let the CI work, and then you try with your tool to pull the container and see that everything works, and then you can send it to your collaborators or use it in your manuscript or whatever. So now, because I don't have a GPU in my laptop, I will just connect remotely to a workstation that we have here. I'll do it with the user interface, just because I think it's going to be easier to follow. So let me see if I can do this. Okay, so this is an Ubuntu machine with our workstation. Here is the repository that is just cloned. And what I'll do is to launch it from the terminal, but you can double click it as well. So basically, I will just go to here, and to launch it, I just need to run this bash. Is an executable file, and then it will ask me for the password. So this is very important in case you want to provide this service for users, or you want to connect with some GPU workstation at your institute. A lot of people ask us, you need to have Docker installed, okay? And in some institutions, I know this is a problem. For the installation of Docker, you need sudo, or you need the developer permissions, right? The root permissions. But once this is installed, you don't need these permissions anymore, okay? It's just for the installation of Docker. and then you can use it freely with your user at your institute. So here, this is the user-friendly interface. We choose what is the collection of notebooks we want to use. So in this case, I will use zero cost. I'll use a unit. This is just for the demo, but you can use any other one. And here is what, Alex, I told you. So here I need to tell to this virtual machine where my data is, right? So I'll need to select in my personal computer or workstation. So here I have a folder with data. I'll say, okay, there's my data. And where I want to save my results. And this is important because the tool will automatically save some configuration files wherever your results are. In this case, I think I'll just, here, yes, I have a folder here, okay. And I will allow the GPU, I have it. If you don't have it, this chance it won't be available for you. If you don't want to fill this again and again, you can also load previous settings. And then if you're a developer and you want to test that your containerization works and so on, we have also the advanced options here. So basically what you could do is give access to the containerization configuration file, like the format. You can say, where is your notebook? Where are your requirements? Where is the Docker tag you want to give? So these options would be for someone, for example, that wants to containerize their workflows. Like you build something in the facility or in your team. You want to make sure that this works. You try it here, it works. Then you publish and you give it to the users so they can use it with these user-friendly kind of chances, right? So it's like a front end for both developers to test it and for users. So then I run. And here it will ask me, okay, you already have a Docker container in your a Docker image, sorry, in your workstation. This is because I was testing it this morning. You can build it yourself or you can download it. So basically, the idea is that we are pushing these images in Docker Hub, in this zoo that I told you, and those are tested. We made sure that those work. So our recommendation is to always pull and download whatever we tested rather than building and replacing it yourself. But if you are testing it, if you are building, if you want to, I don't know, play with it, you can also build and replace. So here we'll just use the Docker.
I have a question about
Yes.
this, because in my trial with deep learning for micEverywhere, I was surprised by the size of the image. It was 2 or 4 gigabytes.
Yes.
So if you want to play with some, not all, but some of the different image, what is the space requirement you will tell us?
Oof. Well, it depends on how many workflows you want to try. So of course, I would say in general to work with these deep learning tools and so on, it would be, I mean, recommended to have at least something like 20, 50 gigabytes free, at least, in your workstations, right? But not only because of that, but also because you may create a lot of data while training, like workflows, they save all the training data once and again. So it's really recommended to have some gigabytes available. Also, yes, this was a criticism of the Docker containers, but the reason is because we are installing the entire Python environment. So if you think about how much space a code environment occupies, is exactly the same. It's also something like 3 gigabytes and so on. So yes, these solutions that require space, but I think in general, if you want to play with deep learning, you will need a space always.
And you don't need to build an image for the storage of the data here. Here you can just pick data on another computer.
Exactly. The data needs to be available in a computer where you are launching the So here we have a workstation, and when I send, here is my data, I'm accessing the data of my workstation. So now, because I'm remotely, I need to copy paste this manually, but in your, it's because I have here all of you in the camera and my screen is very small, sorry. Okay, so basically, it will, when you use it, sorry, copy. Here, and then the token. So if you are not familiarized with Jupyter Lab or Jupyter Notebook, so so when we launch Jupyter Notebooks or Jupyter Lab, usually it's just it will open a port in our computer, right? And usually it pop-ups in your Explorer. It's just because I'm here virtually, I need to do it manually. But some of the users, they were a bit worried about opening ports in workstations, in institutional workstations, because it feels that you are basically leaving some kind of security, I don't know, like hole there. And I would say that there's no issue, basically, because you always need to use this encrypted kind of token that you only as a user have available. So it's really not it doesn't imply any kind of security issue. So okay, this is the I mean, now what I'm doing. I opened this virtual machine, that is this Docker container, right? And you can see it here in my terminal in case you are familiarized with this. It says the CUDA version and so on and so on. But what is happening is basically that I'm launching for the user. In this case, it is completely transparent, right? It will be just playing with the Jupyter Lab and using these notebooks that are user-friendly. Is the same as zero cost. It's the same that you will launch in Google Colab. And then here, maybe I can make it bigger. Let me see if it allows me so you can see. Yes. So here you can see your folders. And if I click here, this is the data that I have in my workstation. So now I'm in the virtual machine, but with only access to the paths that I gave. I don't have access to any other site or any other location in my computer, right? So basically, I can now start using the notebook. So I can launch these cells and this. So basically, is the licensing. It tells, okay, you are using this version of the notebook and so on and so on. I can keep running the cells. And this, we try to make it with the most similar user interface as with zero cost, which it means that we are using these widgets, and so the user doesn't really need to interact with any code. And here, what it will ask me, I will train a network for segmentation, is where are my training input images, the ground truth, what is the model name that I want to give, and so on and so on. And because I did this before, rather than putting all the data again, I will just load previous settings. And why is not loading? Because it's new. Okay. And so I can say, okay, the data is here. I will use this data. So this is from my computer. This is not, I mean, if a user launches this on their own computer, they won't have access to this data, right? Okay, this is completely personal. So I will say, okay, I want to, this is the source. I say home, and then I paste the path. The target is here. This is the ground truth. This is some example data that I have in my computer. And then I will put my model, some name here, and where I want to save the model. So I have another folder that is the results folder. So I can just save it here. So I copy the path. Okay. And this data that I will just try to train a model on it is for segmentation. It has 3 labels: the background, the foreground, the edges. I just want to train for, I don't know, let's say 20 epochs. And I want to say, okay, a batch size of 10, for example. My unit, this is just a unit. It will have 3 poolings. So these are some technicalities that you can check later for each of the notebooks. We'll just go with this. I say load, so it's loading the data, sorry. So this is the type of data that I have, is some confocal images of Bacillus subtilis, a bacteria. And what I want is to analyze this input image and train a model that is able to tell me what is the ground truth, the edges or the boundary of each of these bacteria cells and the inner part. So I will keep going with the options. I'm not explaining much about the methods, but if anyone has questions, I can also answer. It was more on showing the containerization tool. Okay, so here is telling me, do you want to do some data augmentation? So do you want to manipulate the images so we can increase the training data? I will say yes with the default parameters. So now what it does is like it flips and it kind of makes rotations and so on for the data to augment it during the training. Here it will ask me, do you want to use a pre-trained model? And I will say no, because I don't have any pre-trained model. So now I prepare the data. It says, okay, this is the architecture of your unit. Okay. And now it will start training. And so now, sorry, I have your Zoom here. Yeah, so now it's training. And here in the terminal, you can always see what is going on, like if it is training, if it's not. And if you have access to check the, the loading of your GPU or whatever, you can always check it here. It will be, so here you have the CPUs and the GPU should be somewhere. So you can always check that the container is actually connecting with your GPU and so on. But I mean, this is very technical, and I would agree that for users is not that important. And now the thing is that with these containers, the users will launch it, but if something goes wrong, they can just close it, and nothing will happen to the original workstation. Like nothing will be installed in the workstation, and there won't be any issue with that. Okay.
Esti, we have a question in the chat.
Yes.
About the container. Is there a possibility that a hacker might make a container that looks exactly like a deep learning approach, but export data and result it in old server too? So the question is, for security, is there any check of the pipeline on your side?
I mean, so I would say, I mean, not an absolute no, but I think it's a bit complicated in that sense, because they will need to hack our GitHub actions, and
in the end, it's local. So
yeah,
if you install the pipeline is local.
Exactly. I would say no. So basically, because deep learning for micEverywhere is pulling from the notebooks that we have in GitHub. Maybe let me. So if for that to happen, the hacker will need to make a pull request to our GitHub repository, add a new notebook here, right? Okay, yes, there's one chance.
He do the steps, he do the notebook.
And he's with the external. So if, someone can make a pull request to our repo and say, hey, I have this pipeline with this container. and the pipeline lies in their repo. So usually this is very human interaction. We didn't automatize the contributions. So when someone contributes, we usually interact with this person. We make sure that is like a researcher and that maybe there's some publication involved. So yes, I mean, it could be that there's a researcher that starts doing these kind of things, but
there is a little human in the loop that reduces the risk.
Yeah, exactly. So yes, I would say no. I mean, in general, that's not an issue. But also, like, I think it's a good
point.
It's a good point, but it's also a good modus operandi. Like, if you are a user and you want to run a pipeline, you should know where this method is coming from, right? From which publication or who did this pipeline, right? So in our case, we are responsible of ours. The external contributions, we of course don't do it with robots, but it's a good point. But yeah, I think it's very, very difficult.
I have a small question just to be sure. When you set the patch width and patch height,
yes,
it's the size of your real image, or if you have a bigger image, it's just crop a part of the image?
No, it crops an image. Okay, so for this pipeline, this specific unit, what we do is we have 2D images, for example, and they are 1024 times 1024. And what we do is we crop random patches of 256 and 256.
Okay, and so you can crop only one image. That means if your image is quite big, it will just do one crop per image.
Yes, okay, but that is two things. So one thing is when we train the method.
Yeah.
And there is just like the small images, the small patches, basically because we cannot fit in memory huge patches. But then when you do the actual image processing, you will do like a puzzle, like a tiling. And there's a tiling strategy to actually recover the entire image processed. Okay. Yeah, so here, well, I'm just training the model. I think that there's nothing exciting on the model training, but basically, I leave it here. It will take some time that we can use to, I don't know if there are more questions in the audience.
I have a little question related to just a question from Alex. Is do you have some documentation about the notebook itself, what it needs, how it works, or do we have to go in the notebook and see like deep learning formic, the first version on Google Colab? We just have to read the notebook, or did you have somewhere a documentation for each notebook saying the needs, the limits, etc.?
Okay, so the notebooks are self-contained, right? So you can, when you go from the beginning, it explains on each notebook what it does. And like the requirements, how to put the input information and so on. These notebooks, they belong to zero cost deep learning for micEverywhere. So you don't need to launch everything to see what is inside the notebook, right? So basically, when you go to zero cost here, they have the wiki, right? And there, each of the tasks and the notebooks are documented, and they say for which type of tasks each notebook is, so whether it is for cementation, restoration, denoising, blah, 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 2D, 3D, who were the developers, where you can find example data. So basically, these two projects, they are kind of like complementary to each other. So one should go there. And then for the requirements, like if you go to the repo and you go to the notebooks, Colab notebooks, it's very easy to see. I don't know, we'll just click on anyone. It's very easy to see quickly. This is very uncomfortable, sorry. So if I do like this, it's loading the notebook. It's very easy to visualize the notebook directly on the browser and then read all the instructions there and the requirement. Yeah.
Without doing the whole image in Deep Learning for micEverywhere.
Sorry?
Yes, without the need to download the whole image.
Exactly. Yeah. Everything is online and it's the, it's documented there.
For the external one, do you have the same requirement if we want to push some Jupyter, or it's less documented for the external one?
So the external ones are not documented. So the idea, okay, when you go here, let me now just zoom in. So the external, that's a good point. So we don't have, basically because we didn't have we didn't have any external contribution. So what happened to us is that usually researchers, they contribute to zero cost and then automatically that is rendered. And so if you, so one thing we did, the thing is, because the tool is so new, we don't really have. So the notebooks will be listed here, that's for sure. And the idea is that we are pushing these notebooks in the bioimage model. So what we do is that because it's connected, if you contribute the notebook, and this is not automatic, like you will basically interact with us through GitHub, your notebook could be listed in the zoo, for example. So then for us, this is a much bigger project, and Deep Learning for micEverywhere is part of this initiative, is the central point for notebooks, for models and so on. So anyone could see the notebook here and then see if it is from zero cost or not, and then get the link. But it's true that, this takes us, I don't know, just half an hour or something to have the automatic creation of the list. Like, here is this external contribution, go here. My personal recommendation, but this is me as a developer, is that if you create a notebook or a pipeline or anything that you have already in your GitHub repo, it's always good for you to have your own documentation, like written there. You have full control of it. And then what we do here is we just link it. So then anyone who jumps into our repo, is more popular, whatever, will just be redirected directly to your own documentation.
Okay, thank you.
But we can, if you find it useful, we can always do it. It's not complicated. We just have one contribution, and this one is already in the zoo, so it's like, it's already documented. So this is still training. Maybe I can stop it because I already learned something here. So basically, I will just stop here. Basically, if you launch this notebook will do the training faster or slower. So what I have here is just a model. I stopped the training, so it learned until now. And then I can say, okay, evaluate the model, use the current one. You cannot see anything, and I cannot either. So maybe I can see this. No. Okay, so I will just check the model. There's no loss function because I stopped the training, but I can still compute the error map. So now what I will do is, okay, I have a model that learned something and I want to test how good the model is. So I will just go to my data. Here I have some test data and I want to say, okay, please run the model assessment on this now test data. And we can run, so it's loading the images. Taking edges. Okay, and here is the, maybe I can zoom in. Okay, we cannot see the images bigger. Sorry. So basically, it processes each of the images with the original size. So this is what Alex asked. So now the input images, I think these ones were 1024 pixels on each side. So basically, it crops the patches if it is too big. Otherwise, it just input the entire image into the network and it processes. And here, what you see is the ground truth. I mean, the edges are very small, so we cannot see them well. But yeah, we can test. And of course, the model didn't learn a lot. We didn't let it learning too much, so we can see a lot of noise in the edges and so on. But basically, it launches, and then it's if we go to the folder. So maybe now I can show you this. So if I go, now I'm in my system, right? And this was the folder that I created to store my results. And this is the model, like I just trained. So I have access to it. It's saved on my computer. And I have here the report of the model training, right? So basically, it builds this interaction between the virtual machine and the data that we have in our computer. And if I go to the quality control, here I will check just the image. It creates a PNG image if you want to use it for the cover or something, or you want to visualize it, of what I just launched of the test. And here we have the report. So basically the accuracy metrics for each of the images in the test data set, and like all the name of the test of the files in the test data set. Sorry, I disconnected. Okay, and then here it basically saves the predictions as TIFF files, and we can access all of it. So now, if I'm done with this, I can just close the browser. Here I can say Control-C, or I close my terminal. Yes, I want to exit. And then it will just close the container, it will close everything, and we are done. And nothing in the software of our workstation will be touched. And if I want to launch it again, I will just need to launch again the same bash, and that's it. So this is a bit the way it works. I don't